Okay, let's look at one application of the integral. Let's look at this one. Okay, here. So there's, in economics, there's something called consumer surplus. There's also something called producer surplus, which is the same idea, same type of analysis. So let's focus on consumer surplus. So here we have what we saw before earlier. We had a demand function and a supply function. Okay? So we didn't talk that carefully, though, about what this really means. So what does it mean? So, by the way, in this picture, different than I drew on the board, the x-axis here is Q and the y-axis is P. Usually we have it the other way around, or I'm sorry, the way I did it, it was the other way around. The standard way of doing it is this way, but in some math books they do it the way I did it. Okay, so anyway, here we have Q here and P here. So what does this blue curve mean? It's called the demand curve, and we thought about it before, and we said that it should be downward sloping, right? Why should it be downward sloping? That means that as the, well, let's think about as P decreases, as the price decreases, we expect the quantity to increase. But what does that mean? What are we talking about here? Anybody explain that? Can anybody explain what that means a little more clearly? What does it mean that as the price, what does that mean? The price decreases, the quantity increases. What does that mean? So I think for about 5 years, I said it slightly incorrectly. So maybe you're going to say it incorrectly. I don't know. What do you think it means? What does it mean? Unless, maybe you've studied it. Actually, I had never studied it, so that's why I said it incorrectly. But anyway, what does that mean? Well, everybody, always says, oh, sure, as the price decreases, the quantity increases, or as the price increases, the quantity decreases. But what are we talking about? Okay, he said the demand gets less. Right, that's another way. But I guess what I'm saying is, how does the price decrease? Or I'm sorry, what does it mean that the quantity increases when the price decreases? What quantity increases? Yeah. There's oversupply, but what quantity increases? Let's be a little bit more specific. What? Yeah, but okay. Well, I think what we have to say is that the quantity increases means that the number of people who will buy it increases. So the idea when they say that is that if the price is, let's say, up here, let's say, suppose this is $100 or something, then there are going to be some people who are willing to pay that. Okay, that's the idea. There are going to be a certain amount of people, let's say 10 people, who want this thing and they're going to pay that price, but not, say, only 10 people. What happens if you decrease the price? So the idea is, of course, those 10 people will pay for it, but there'll be new people as well. Okay, so that's the idea, that those 10 people are still going to pay for it, right? But there'll be new people as well that will pay for it. Okay? Okay, so what is this thing called consumer surplus? So what it means is we look at the demand function. So suppose the price was up here. How many people would be willing to pay for it? this many, right? We go down, and this many people would be willing to pay for it, right? This quantity, okay? Or suppose the price is here. Now, more people are willing to pay for it. This many people are willing to pay for it, right? Now, the idea of the analysis is that there were these 10 people who would pay all the way up here, right? But we're not going to charge them that much, right? Right? Because the idea is we don't discriminate. What do they say? We don't discriminate. I forget what they say. Discriminate on the cost. Or anyway, we don't charge different amounts to different people. Now, we could do that, but generally companies don't do that, right? I mean, if you were making your own business, you could, try and say, oh, well, this guy's willing to pay $100, so I'll charge him that. And this guy's only willing to pay $50, so I'll charge him that. So you could do that, but generally when you go to the department store or the supermarket, they're not doing that, right? So they fix the price, right? And so all these people that were willing to pay a higher price, they get a kind of a bargain, in some sense, right? So how much, so that means that the seller is kind of losing some money that he could have squeezed out of those people, but he's not doing that because he's decided to sell it at the same price to everyone. Okay? So you can say, in some sense, how much is he losing by acting in this way? Okay? So let's ask, how much money does he actually get? Or she? How much money does she actually get, the seller? Okay, so, well, price is here, and the quantity is here. So the revenue is what? The price times the quantity, which is exactly the area of this rectangle, right? But we said that, they're losing some kind of money. So where's the money that they are losing? So there were let's say there was one person here, and they would have paid way up here, right? So how much? So how much would they have paid? This price up here, and maybe one person was willing to pay that, so it would be 1 times that height, right? And then the next person, there was another person who would pay a little bit less, right? And so how much would they pay? It would be this height, and then 1 unit there, right? So you get so the amount that they would really be willing to pay is a bunch of rectangles that kind of extend up into this area, right? You understand? A bunch of rectangles that would extend up to here. You agree? So if I draw it on the board, maybe it's a little bit easier. So we have this curve, right, like that. And so the first person, we could have gotten that revenue from them. And the next person, we could have gotten that revenue from them. And the next person, we could have gotten that revenue from them. But we're going to decide on this price, so we're going to get this revenue. Okay? So we're not getting this, and this, and this, and so on. Right? So we're missing a certain amount in this way of speaking. Okay? So, now, if this wasn't one person, but this was like 100, and this was 200, then one person would be right like there, right? One person would be right here, and 2 people would be right, really tiny intervals, right? So if you did that, basically you'd be having like this, and this one, and this one. They'd be all right next to each other, right? And basically, you'd be talking about this area as the amount of money you'd be losing as the seller. Okay? So, that's called the consumer surplus. It's because, that's like something the consumer gets. Basically, the consumer is getting this benefit. Okay? So it's called the consumer surplus. is this area, right? Because the consumer as a whole is kind of benefiting by that much because of this process of selling, of not, what do they say, not discriminating on price or something like that. Okay, so by deciding a single price for everybody, there's a certain loss. And this is it, right here. Okay, this makes sense? So, but remember, what does this stand for? What did we say this stands for? That stands for, what we talked about last week, was we have some curve, and it's the area under the curve between A, 0, and B, for example. Right? We talked about this last time, right? Okay? So, I can also, so of course I can take the demand curve and do the same thing. I can write the integral of the demand curve, whatever that is, d of q, d of, what do they say, q, yeah, dq from 0, this is the quantity, what do they call this in this picture? QE, the equilibrium price actually. Okay, but whatever we call it Q something. Okay, so we can integrate between 0 and QE on the demand curve, and we're going to get the whole area underneath it, right? Okay, so whatever the form of the demand curve is, like let's make a simple one. How about if the demand curve was equal to Q squared? Now that doesn't make sense because it's actually just the opposite, right? Q squared would be a curve like that, which is wrong. But just let's pretend, just for the math example. So then we'd be talking about the integral of Q squared between 0 and some other QE. Well, let's say QE is equal to 100, just for example. Okay, so we just do integral. Okay, whatever the integral is, we'd find the area under here, the whole area. Okay, and then what's the consumer surplus? It's the whole thing minus this square, right? So we could say the consumer surplus would be, the whole thing minus, what is the area of that square again? It's just P, I think they call it P epsilon, P and equilibrium, what's some price, times some quantity, whatever you want to call it. Okay, so this is the consumer surplus. Okay, so, it's like we're not going to use Q squared, that doesn't make sense economically, right, but we can make some other function. Okay, and then we do the integral of that other function, and then subtract the rectangular region, and that's called the consumer surplus. Okay, so that's one example from economics of where you might use the integral. Okay? All right, now I was going to go through more specific, clear definition of the integral, because I didn't go through the details. I just told you that it's the area, and I tried to explain this idea of rectangles, but I was going to show it to you in more detail, but I think I won't do that. I'll just leave it at that one example, okay? There's many other examples, but there are several other important examples, but I won't do that right now. I thought for fun, I'll go into something about artificial intelligence and data mining and neural networks. So it's something I used in my seminar last week, a video, and the week before. And I thought I'd just show a little bit of it to you. Okay, maybe you'll get interested. So the problem that he's going to try and solve is he's going to take two inputs. I think he calls them, I don't know what he calls them. Let's call them x1 and x2, but they are the number of hours that you studied last night and the amount of sleep that you got last night. So let's say, how many hours did you study last night? Let's say 4 hours. And you slept 7 hours. And then let's say and then this is the grade you got on a test today. Okay, and then if you studied, let's say another time, you studied 3 hours, but you got 8 hours of sleep. Okay, and then another day you studied 5 hours and you only got 4 hours of sleep. Okay, and what was your grade? So we're going to try and build some kind of model that will take in the number of hours that you study and the amount of sleep that you get and try and predict your grade. Now the grade here is going to be measured like, 89%, not as a B, a C, or a D, but like a number, like 89%, 64%, 72%, right? We could say this is A, this is C, and this is B, or something like that, but we're not going to predict it like that. We're going to try and predict the actual numbers. Okay, now that, that's important, but, which way you're going to do it is going to change the way you have to work it out. Okay? So, and we're going to study very briefly, and it's going to be much too advanced for us, but we're going to study very briefly what's called a neural network, which means you have a bunch of what are called nodes, and you have here, you have one set here, and then you have another set here, for example. Then you might have another set, but I'll just draw it like this. And let's say you just have one there. And then you have, from each node here, you have a line connecting to each line there. I'm sorry, to each node there. So you'd have that, and that, and that. You'd have that, and that, and that. And you'd have that, and that, and that, right? And same thing over here. Okay? And what you're going to do here is you're going to use, this is going to be your input, what's called the input layer. These are called layers. This is going to be called your input layer. And the input layer is going to be the 4 and the 7, or the 3 and the 8, or the 5 and the 4. So actually for our problem, we only have 2, not 3. Okay, let me erase some of those. Okay, we only have 2 because we only have the hours slept, and studied, right? So for example, we might put in the first case, we might put in 4 into here, and 7 into there. So this is the beginning of building this thing called a neural network. Okay, now, next, we have some, what we call weights here. So we're going to have a weight here, and so let me draw this again. So we have 1 and 2, right? Just those two. So W1 and W2. And then we're going to have another one, let me draw it in red. We're going to have another weight. Oh, I left out something. Leave that one out. Oh, sorry, what am I doing wrong? Yeah, that's right. And then I want to have here, and what did I do wrong? This one and this one go to here and here. This one and this one go here and here. Okay? And then I need another color. White. Okay, so that and that. Okay, is that too messy? It's kind of messy, right? Should I clean it up? Draw it again. So we're only going to have 2 what we call input nodes. We're going to have, I'm going to say, let's have 3. Now you can change the structure, and according to the way you change it, it'll either give us better results or worse results. What do I mean by good results and bad results? So I'm going to put in a bunch of these rows. This is my data that I'm going to start with. And then I want to just arbitrarily, so this is real data. Like when I did 4 and 7, I got an 89. When I did 3 and 8, I got a 64. When I did this and this, I got a 72, right? So then I want to sort of what we call build, train the network. We want to train the network with this. And then afterwards, we want to say, oh, well, what if, tomorrow, what are you going to predict happens? And then we want to see how well it works. Is it going to predict correctly or not? Okay? So the question is how do we build this so that it's actually going to make intelligent predictions? So this kind of thing does make very intelligent predictions. For example, all of Google and Facebook's face recognition uses that. All of Google, whenever you speak to, what's it called? Siri, and Google's okay Google, right? Okay Google. Let me try that again. Watch this. Okay Google, play Puccini on YouTube. Oh, wants me to sign in for some reason. Okay, Google, play Puccini.
All right, here's Giacomo Puccini on YouTube.
Okay, anyway, so how did that work? That was using this exact technology. Okay, it's listening to sounds, which are waves, that's all. It's picking that up, and somehow it's doing this. It's actually playing it.